Hey guys, welcome to what I hope is the final installment of the Philco 90 restoration series. Now, towards the end of the last video, I talked about doing a few things in the next installment. One was to go over the chassis and how it relates to the schematic, and that's what we're going to be doing to start out with. I also talked about replacing the tuning cap with the one from my parts chassis in better condition. I decided against that. This radio is working fine. I don't want to mess with it. So what I did do since we last left off is I finished cleaning up the chassis a bit, removed some corrosion from the tube shields, reinstalled all the tubes and made sure everything's still working, and we are good to go. I did, however, remove the tuning cap from the other chassis. We can take a closer look at that. But first, let's go over this chassis. So what I thought might be interesting is to go through the schematic and give you some idea of how to go from this to this. Now you might be wondering, well, why didn't I do that in the first installment? Well, honestly, I couldn't. At least not in the depth that I can now, and that's because I'd never worked on this chassis before. Regardless of how many radios you may work on, how much experience you may have, if you've never worked on a particular chassis or brand before, you don't know everything. Or even if you did know everything, over time you forget everything. So at least some things. So for example, when I first started working on this, I was wrong about some of my assumptions about what coils were what, and what. For example, I'll give you a simple example. So the antenna input is down here. So I assumed the antenna coil and RF amp were here, because you would think that's the first thing you want to do. It's the first thing on the schematic is you go right from the antenna jacks to some coils and then a tube. So that would be this stuff, right? No, it's not. So let's go through it. First off, the schematic. Standard layout is to have the input on the left and the output on the right, and quite often the power supply somewhere down at the bottom, either left or right side. And the oscillator is often over in this area. You get into AM FM radios or multi-band shortwave stuff, things could get a little more complicated, and if you go into really early radios, things hadn't been standardized so much, even some of the symbols look a little different. But by the time we get to about 1930 or so, things were pretty much standardized. So on the far left, we have our antenna input. And on the far right, we've got our speaker. Alright, so let's start off at the beginning. Antenna ground. Those are two inputs, two jacks. Those are these guys. They're called Fein stock. I think that's the guy who invented them, or the company that made them. They're little clips for you to, take a stripped piece of wire, you push down on this, you stick it in, you let up, and it holds it in place. That's ground, it's riveted directly to the chassis. This one is insulated, that's your input. Okay, after that, we've got two coils of wire, and with the number 2 pointing to it. When you see one part designator pointing to multiple elements, it's a pretty good indicator that these are one piece. So if there was a 2 and a 3 pointing to each of these individually, there could be two separate coils. But since there's one designator pointing to it, it's a good indication that it's a single part, even though there's no dashed line or anything to indicate that this is all one unit. But it is. So where is it? How do we find it? Let's take a look underneath the chassis. It's not where you might expect it to be. I have the chassis on its side now, so we can flip around from top to bottom pretty easily. So here are our antenna inputs. And on the bottom, one of them, the insulated one, the one labeled ANT, there's a wire going to it, a red wire. And it goes up and up and up and up and up until eventually it goes in way over here. So yeah, the antenna coil is nowhere near the back of the radio. It's on the front of the radio, next to the tuning dial. And so that's the antenna coil. How else might we know that? Well, there's one resistor going to that coil. It's a 10K resistor. If you look around on the schematic, I think it's the only 10K resistor in the entire circuit. They show it right here. It's in parallel with the primary. So that's another way you can find components. Now, having a parts locator, of course, is a treat. But you don't always have one of these. Well, this points to everything and tells you what it is. So, for example, number 2, that coil, there is a number 2 here pointing to it. But if we didn't know that, if we didn't have that parts locator, that's how you do it. You identify some key points, trace out the wiring, and look for component values that match to help guide you. Here's the tuning cap I took out of the other radio, and boy, this thing is beefy. I'm going to set it down here. It's got to weigh a good 6-7 pounds, I would guesstimate. The main body of it, I'd say the steel for that is as thick or thicker than the radio chassis. I'm used to working on tuning caps made out of aluminum, not steel. I think aluminum just may have been too new of a product, too expensive to use back then. I mean, they did use it for the tube shields. I mean, sorry, for the coil shields, but not this. Or they did it for stability. Aluminum plates, well, they can bend more easily than steel. All right, so we've got 4 sections. These are all independent. The bottom sections are all connected together. These are all ground. The whole frame, all the fixed plates, that's all grounded. But these 4 top ones, these are independent, but they move together. It's to make each of the tuned sections track along with the local oscillator. And they looked all to have the same number of plates, meaning they all have the same variable cap range. So they must have chosen the other circuit components, the coils in other words, to be of such a value that everything works right with the same variable capacitor range. Now, if you're wondering how does this work, how can you have moving plates? And hey, you know what? I was wrong. I like being wrong. So that means I get to explain more. The bottom ones are not grounded. The bottom ones are isolated. It's the top ones that are grounded and all connected together. And that is because they have a common shaft, and there are wires, very stiff, spring steel probably, wires that rub against that shaft. If you have a radio that's got that kind of crackles or does weird things while you tune it, that's something you might want to check. Spray some deoxit in there. Clean up the metal on metal contact. And it's so crucial, you'll see that they had 1, 2, 3, and then this back one as well, so there's like 4 grounding points. And on the frame itself, ground, ground, ground. They had multiple ground connections running up to those wires. Even though those wires are all connected to the frame and everything is connected together, they still grounded them each independently. Critical to the operation. And then here are the 4 isolated fixed plates. And the connections that go down to the radio. So if I wanted to swap this with the one that's in my radio chassis right now, you have to do 4 independent wires coming down, the 3 ground connections, and the dial lamp up front. That's why I didn't want to mess with it. On the flip side, we've got these things. What are these? These are trimmer caps. Manufacturing tolerances were not perfect then, and not perfect today. So to get these all perfectly tracking and operating in the range they're supposed to be, they have these trimmers. What are they? Well, it's a fixed piece of metal and then a flexible piece of metal with a sheet of mica in between with a nut. You crank down on that nut. The more you crank down, the higher the capacitance. That's part of the alignment instructions. And then the whole thing rotates on a common axis, and that goes to your tuning dial with a dial lamp backing it. So, in a way, this is the heart of the radio, or certainly the heart of the tuning capability of it. Alrighty. So, what did all that go to? Well, 3 of them, I believe, serve the same purpose. This one, and this one are all connected up with transformers that carry RF. So I believe these are all acting as bandpass amplifiers. So say you want to tune into your AM1000, rather than letting a flood of the whole RF spectrum come into the radio, it helps if you can limit it to around 1000 kilohertz. You don't want it to be only 1000 kilohertz because you need a little bit of bandwidth. As that AM modulation does its thing, it makes the carrier a little bit wider than just exactly 1 megahertz. So you want to go, say, 1 megahertz plus or minus 10 kilohertz, something like that. So that's what these three would do. And they need to track, and that's why they've all got all these trimmers on here, to get them all tracking together, so when you tune across that dial, the bandpass filter is working in concert. And the fourth one's the easiest one to explain. That's a local oscillator. You vary that cap, it varies the frequency of this oscillator. This transformer here, these coils, that is the oscillator. So this capacitor, in conjunction with this coil, sets your local oscillator frequency. That, I believe, is feedback to keep it going. And then this coil here picks it off and feeds it up into this, which is the mixer tube. Output of the mixer goes to this, which is our IF transformer. So I misspoke about that. These, oh no, there isn't, never mind. Yeah, this, oh, there is no variable cap here because this is fixed. So from here, at this point, we've got our IF frequency of 175 kilohertz. After that, we've got another transformer which should be tuned to 175 kilohertz, and then we get our detector. Now, a number of you pointed out, hey, that's kind of weird. They're using a triode for the detector. Yeah, and if you look up the data for a type number 27 tube, it'll say it's a detector amplifier. It was designed from the beginning to be used as both an amplifier, typically the audio frequency range, and a detector, a diode in other words. Well, why didn't they use a diode? Simple. I don't think they had come out with any dedicated diode tubes yet back then. Rectifiers, yeah, power rectifiers like the 80 down here, but not small signal sensitive. I think the 6H6 was the first sensitive dual diode that you would use for a detector in a radio. Prior to that, you would take a triode and rig it up. Notice the plate is grounded. Yeah, that's weird, but that's how you make this act, so that's kind of out of the circuit, and your grid and your cathode are acting as a diode. And that feeds into the same 27, but now we're using it as an audio frequency amplifier. Another audio frequency amplifier, driving the final 47 power output tube. Later on, not too much later on, mid-30s I'd say, they came out with, I think it was the 6Q7, was the first tube where they put two diodes inside the envelope with a triode. In other words, they combine these functions. Why two diodes? So you can use one for the detector to turn the IF frequency into audio frequency, and one for the AFC, or AVC, automatic volume control. In this radio, they kind of use one diode for both functions, but that's why there's often two diodes. One to detect the signal, and one to condition it to be used for automatic volume control. And then down here's power supply. Power transformer, 80 rectifier, or 2 rectifier tubes, our dedicated filter choke. And there's a field coil on the speaker, and there's the speaker. The output transformer, tone control right on the plate of the output tube, and there's the output tube. Alright, I'll do like the schematic and go left to right. So we have our antenna input down here. It goes all the way up here. Antenna coil. Second antenna coil, I'm going to call it, or second RF coil, going into the RF amp. This is the local oscillator tube. That threw me at first. When I first looked at this radio, I thought the local oscillator was down here, but no, it's right after the RF amp, even though it's not right after it on the schematic. I thought that would be the IF tube, but no. That is the mixer tube. So we got RF in, local oscillator, mixer, and then our IF tube is over here hiding underneath this cap. And then we come down and this is our detector. And we've got a couple 27s down here. That's our detector amplifier, first audio frequency amplifier. We got our 47 final output power amplifier and 80 rectifier tube. Power supply, lots of big old transformer down here, and the 80 rectifier is right over here. Here's our big biasing resistor and our filter caps. Well, they were originally over here. I relocated one here and one over here. Filter choke. The rest of all this stuff, those are all the caps. A lot of them are bypass. Well, two main functions are bypass and coupling. A few others are used for some other purposes, but generally they're used for bypass. What do I mean by bypass? I mean if you've got two resistors forming a voltage divider, like here we've got a 25K and a 70K to ground. They got a 1 microfarad cap here just to filter out any noise from that line. And many caps like here and here and here are used to couple the signal from stage to stage to stage to stage. We've got some specialty caps for tone control. We got a specialty cap here for the AVC. And we've got some mica caps here and there for the local oscillator and for the detector. So it all sounds simple enough when I say all that, but when you actually go to work on it, things can get confusing. Now, part of the reason why is like, why is this stuff scattered all over the place? Why are things not why is it not laid out on the chassis like it is on the schematic, which is a logical bam, 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 bam? It's because they couldn't. You've got to go from this to a rectangle that will fit into a box. And with parts back then, for example, say a 1 microfarad cap, they were big. And since they're going to be big and intrusive, let's put a bunch of them inside one box. So we've got 3 or 4 caps inside of this box and 3 or 4 in here. But just because this is located here doesn't mean the circuits it goes to are right around it. No, you got wires running all over the place. So when they went to lay this out, I'm just putting my mind in, you know, as if I was an engineer back then. There's certain things that are going to dictate your layout. You got this giant tuning cap. That's going to, I would think, be your starting point. And that goes smack right in the middle. Power transformer. Big old heavy thing. It's got to go in one of the corners. And that's going to establish where your power supply stuff is going to be. And you probably want to have your power supply on the opposite side from your sensitive RF, IF stuff. And then you kind of go from there. There's certain dimensions to the coils and to the tubes, so you kind of lay them out. So I kind of figured they did the tuning cap, power transformer, filter caps, transformers, tube sockets, and then whatever's left, that's where you start sticking stuff in. Your caps, like, why is the filter choke here? You'd think it would be down here with the power supply. Why is it right underneath the tuning capacitor? Because there was a space there, I got to imagine. Logically, it should be down here or maybe over here. That's where it's used. And so we've got 2 wires that run from it and snake all the way down into this stuff. So it can be confusing. You got my sympathies if you've never worked on one of these before, or if you got one that's giving you a lot of headaches. And especially some of the more compact ones or multi-band radios, things can get really, really messy. So when I started out, I said this was a simple radio. And conceptually, it is, with each stage being kind of separate and distinct and clearly labeled. But when you've got to actually make it happen, things can get a little complicated. Like, another example, doing the alignment, the trimmer caps. I think they kind of just had to stick them wherever there was some space. So one of them ends up being sticking out the back of the chassis, and several others, they drilled a hole through the chassis so you could get to them. Later radios, they put them all in the back, like the Type Model 60, so you could adjust them all from the back without having to stick your hand inside the radio chassis. And later on, radios, as we'll see, I'll be doing some more radios soon, they started getting smaller and smaller and smaller. One of like the tuning cap, they went from this to aluminum, which I think helped to make it not only weigh less but smaller. They put the plates closer together. Manufacturing techniques improved. Coils got much, much smaller. So why were these coils so gigantic back then? That I'm not entirely sure, other than just limitations of maybe these were hand wound, or the machines they had, they needed to be big enough that they could see them and work on them versus having the stuff be really small and you could automate the process. And then of course this was all hand assembled and hand wired, so they had to, make it big enough that you could get in there and work on it and see what you were doing. Which is one of the appeals I have with this hobby, is that it's repairable. You can see it. You can get in there with your hands and you can move wires around. You can replace stuff without needing a magnifying glass. All right, I hope that made some sense about how to go from the schematic to the real world and how the stuff kind of works together and how they assembled it. A key thing to remember is a lot of the stuff, they did it because they didn't have a choice, because parts were physically large, or they had to put them where there was space left in the chassis, and no, it may not make sense. And that's why sometimes when I restore these, if I don't restuff the caps, I'll relocate them, because it just makes more sense. Like this cap's got a wire going all the way down over to here. Why not just put the cap over here instead of having this wire run all over the place? Oh. In this case, I wanted to preserve the look, the original wiring, but from an engineering standpoint, no, this is not the best way to do it. They just had to compromise. Okay, let us put this in the cabinet finally. No, I haven't done anything to this cabinet other than clean it up and replace that damaged arch. I may, at some point, spruce up the finish a little bit, but not today. I'm kind of low on refinishing supplies, and it's winter, essentially, so I can't really spray too much, but I want to get this back together, so that's what we're going to do. Now, the chassis sat in this cabinet on top of 4 rubber washers. That's very common for radios from the 30s to be assembled that way. Just like with the tuning cap being mounted on rubber washers, the chassis was to reduce vibration from the speaker feeding back into the circuitry. They're always going to be rock hard and crumbling and disintegrating, so we need to replace them. Well, I happen to get these, which are pretty close. I think the originals are 1 inch in diameter. These are 7/8. I believe I got them from Renovated Radios, who's no longer in business. I think Radio Days might have them, or Anti-Electronic Supply might have them. Otherwise, you just do it like we did back in the day, which is to go to the hardware store and find what you can. The great thing about Renovated Radios and other restoration supply vendors is they figured out the density of this rubber, and they're very close to what they were originally, and as well as the thickness. You can see it's a little bit thicker than it was originally. Now, they sold these in various thicknesses. I don't know that this is correct for this radio. Over the years, I bought these for various projects. They all kind of got lumped into the same parts bin. We'll see. How will I know if these are right or not? Simple. There are holes in the front of the cabinet for the controls. When I put the chassis in here, it's going to mush these down because it's heavy. And then there are bolts that go through the center. That's why there's a hole here. And then to the chassis, and you tighten those down, it'll move it down. If it's such that when I got it tightened down and there's still some air gap and it's got a little bit of give but not too much, and the controls all line up, then we've done a good job. If it's bottomed out and the controls are banging into the bottom, or these are too thick and they're rubbing against the top of the holes, then we didn't do a very good job. I think we'll be okay. I do need to remove the remains. Two of these are still, they're kind of glued down into the cabinet. I gotta pop those out, and then I gotta dig up the bolts. And that's another topic to discuss. Here are a couple of the original chassis bolts. Good old Philco did not use standard thread pitches or bolts on their chassis, unfortunately. So it can be tricky to get a modern machine screw that will fit properly. I see I have two of these. I need to find two more. I have salvaged various bits of Philco hardware over the years. I think this is a... No, it's the right threading, but it's a bit longer. It might work, but probably... Well, we'll keep it out. It might work. If I've only got two, well then we'll just go with two, but if I really want to snug this chassis down on those rubber mounts, I kind of need all four. Well, I will have to keep hunting around. Meanwhile, I'll at least get started on it. Yeah, I'm not seeing any in this pile. I don't remember when I took the chassis out of this cabinet, but I'm guessing it only had two of the bolts present, because that's all I could find. I went and installed the modified Model 20 speaker for now, just so we can hear it playing all back together. And I got my 4 spacers in place, and I did find 4 of the correct bolts to use. Now I will warn you, this can be very frustrating, because what's going to happen? I'm going to slide the chassis in, and he's going to get knocked out of place. Or even if we're lucky and they stay in their little recessed areas, they're going to get knocked to the side, and they're not going to line quite up properly. I don't have any hints or tips other than sometimes it can be helpful to have this on the edge of your workbench so you can slide it over so you can get your bolt in from below without having to tip the whole thing forward. Tipping this on its face is not going to be too useful usually because these are going to come loose and they're going to fall out and they're going to go to the front of the cabinet and you're going to be swearing. So do your best. What's tricky is you have to kind of lift it up to get over these, but you have to get it low enough that it can go through the holes in the front. So kind of come in at an angle and then go down as best you can. I haven't really tried it, but maybe it will be helpful to kind of put these in place first. Sorry about that. Got a spam phone call. So let's see, if I put the bolt through, they're just going to fall out. So that's not too useful. Alright, I will do my best. I got to get this, actually, I guess that eye-tube hole that's still there will come in handy because I can stick the speaker cord maybe into it. Well, at least maybe I can loop it over the top. Come on, stay. Alright, well, I'll use a rubber band or something because I want to get this speaker plug up and there we go. I want to get that up and out of the way. So here we go. Yeah, it's big and it's heavy and it's awkward, but we'll do our best. Here we go with attempt number 1. It is big, it is heavy, it is awkward. Well, those spacers do work out very well. I got the bolts done in the back. Everything is nice and snug, and everything would be wonderful, except that I don't have them up front. I just got too darn frustrated. The controls don't line up in the front that well, and these kept getting knocked out of the recesses. I'll turn it around and show you what I mean. Here it is from the front. These three are in pretty fixed positions. They're in holes through the chassis. There's not much you can do about it. But the tuning one, that's the one I replaced the rubber mounts on, and it's off down to the right. So, two issues. The spacers I'm using are, well, maybe I just tightened it down too much. It should be up higher. It should also be over to the left a little bit. So, although I'm not crazy about having to pull this thing back out again, if I really want it to line up, that's what I need to do. So I'll just remember, loosen them and move it that way too a little bit. But I'm still a bit of a loss as to how the heck I'm going to muscle this in. So here's the problem. I need to get there are little not squares, there's like 1-inch squares of metal in each corner of the chassis. So you can see on this parts one down here. So I need to get the chassis sitting on top of this for the weight to mush it down. But as I push it towards it, the edge of the chassis knocks it out of the way. I can't lift it and drop it straight down because the controls stick out. And there's just not much enough clearance that I can really come in at that much of an angle to kind of come down. If these are a little bit shorter, yeah, it would be easier. But if they were much shorter, then they wouldn't be doing any good because the chassis would just be sitting on the wood. And then, you know, as it's sitting on the wood right now, you can see they do line up pretty much as is, so I don't need a whole lot. I mean, these do need to get compressed down. Could I leave it without them? Yeah. I got the rubber mounts in the back. That'll help somewhat. It would be nice to have them in there. I could find some flatter ones. Heck, I could put the old mushed down ones back in and glue them in place, I suppose. And yeah, in the past I think I did try using rubber cement or something on these, but it doesn't really work too well. I mean, nothing really, these are rubber, nothing much sticks to it very well. Trying to glue rubber to wood doesn't really work too well. Plus, I don't want them to be like, you know, they're meant to be replaced if needed down the road. I don't want to permanently affix them. I found some rubber mounts that were about 2/3 of this thickness. I used those in the front with a bit of finesse and a lot of swearing. I finally got it mounted properly. Now I'm putting the knobs on with a little bit of felt washer behind each one, so when you rotate the knob it doesn't dig into the finish. Let's make sure it still works. Eventually I'll order up some grill cloth so we can cover up that hole where the eye tube had been added. Let's see.
Hearing Health Center 3-year warranty. Right. Just call 833-GO-HEARING for a gift certificate at any Hearing Health Center office. Chicago Streeterville, Oak Brook, Parkerville, Highland Park, or Park Ridge.
I thought the evidence was overwhelming.
Or visit starregistry.com.
So that's going to be it. I hope you enjoyed this lengthy, in-depth restoration series on a classic Philco 90 cathedral radio from about 1930. Oh, wait. No, we're not done, are we? No. We still have a matter of that pesky speaker to repair. We've got an open field coil to patch up, a paper cone speaker to stiffen up and patch up, and we have to rig up some kind of output transformer and put it all back together. Well, so there'll be one more installment, and hey, then we get to compare the sound quality of this rigged up Philco 20 speaker and the speaker that would have come with this radio originally. So stay tuned, one more installment to go.